Okay, students, welcome once again to the session. So, we were doing some questions or exercise based on properties of the determinant that we had already discussed in the last lectures. So, in continuation or in this sequence, let us have one more example based on properties of the determinant. So, here in this example, we have to prove that the value of this determinant is equals to 2 times of the determinant this, right? So, see here we have learned or we know a property of the determinant that if any column or any row of a determinant is the sum of two numbers, then we can decompose that determinants into sum of two determinants, right? Any row or any column of a determinant is a sum of two numbers, then the given determinant can be decomposed into sum of two different determinants. So, we can use this property here to prove this result. See, the first, second and third column, all the three columns are the sum of two numbers. First column B plus C, Q plus R, Y plus Z. Second column C plus A, R plus Z, Z plus C. Third column is A plus B, P plus Q and X plus Y. So, all the three columns are in fact the sum of two numbers. So, we can use either the property, we can decompose this determinant into 6 different determinants, because if you look at two numbers in column 1, two numbers in column 2, two numbers in column 3. So, the given determinant can be decomposed into sum of 6 different determinants, but that process is somehow lengthy. You can attempt this approach at yourself at home, but I would not like to use this approach. Rather, I would like to use the approach which requires the least calculation. See what we are doing here. We are using this application. C1 plus C2 means first column and second column are added and third column should be subtracted from sum of the first and second column. So, first add C1 plus C2 and then subtract this sum from C3. So, take one case. The first element of the first column is B plus C, right? C1 plus C2, B plus C plus C plus A. What we will get here? B plus A plus twice of C, right? And this should be subtracted from C3. C3 is what? A plus B. So, minus A minus B, B and A will cancels out. What is left? You are getting here 2C. We are getting 2C as the first element of the first column after using this operation. In the same way, we should use the same operation in second and third all. You will get 2C, here we will get 2R, here we will get 2Z. Column 2 and column 3 will remain as it is. For 2, you can take also this, add C1 plus C2, that is C1 is Q plus R, Q plus R, this is your C1, Q plus R plus P. What is sum of these two? This is equals to 2R plus P plus Q, and this should be subtracted from C3. C3 is this, minus P minus Q, P and Q will cancels out. What is left? That is equals to 2 times R. So, we are getting 2R. Likewise, you can find out 2Z. So, after using the operation C1 plus C2 minus C3, we are getting this determinant. See what we want to achieve. We want to achieve the right hand side. The first column is APX, second column is BQR, third column is CRZ. Or you can read in terms of rows. The first row is ABC, second row is PQR, the third row is XYZ. Now you can take 2 outside. If you take 2 outside as common, the determinant left is what? CRZ as the first column. second column and third column, it will remain as it is. Clear? Up to here, I think everything is clear. Now, with the same determinant, what we are using next? We are using C2 minus C1. C2 is this column, C1 is this column. So, C2 minus C1 means C plus A minus A. A and A you will get cancelled. What you will get here? C. Right? Sorry, C plus, this is C2 minus C1. So, C plus A minus C, sorry. C2 is this. This is your C2 and this is your C1. So, C2 minus C1 means C plus A minus C. C plus A minus C, this will cancel out, you will get here A, this is A. Then R plus P minus R cancel, you will get here P. Z plus X minus Z will cancel, you will get here X. So, APX, the third column will remain as it is, right? 2 will intact. So, after using the operation of C2 minus C1, we will get this determinant as a new determinant. So, what is left here? This is A plus B, this is A. If we subtract C2 from C3, right, A plus B minus A, you will get A and A will cancel out, you will get here B. So, we will using C3 minus C2. See, C3 is what? A plus B minus A, you will get here B. P plus Q minus P, you will get here Q. And X plus Y minus X, you will get here Y. So, BQY is the next column of the new determinant if we are using this operation. So, 2 times CRZ APX BQY, what we want to calculate? APX, say APX, here is the first column, here APX is the second column. So, if we interchange these two, the determinant will become negative. So, this determinant 2 CRZ APX BQY, this can be written as minus times 2 of what you will get here? APX, right? CRZ and then APX and CRZ BQY, this. Now, APX, after that BQY. Now, interchange these two columns again, third and second. So, minus again, minus, you will get here minus plus 2 APX, then BQR and then CRZ. This is the required determinant. So, here in these two lines, we have used the property that if any two adjacent columns of a determinant are interchanged, the value of the determinant becomes negative. So, by using this property 2 times, first, second and first column is changed, then third and second column are changed to achieve the required determinant as given in the question at the right hand side. So, finally, we will get 2 times of ABC, PQR and XYZ. That is what is required here. So, the next case is what? The value of X, if this determinant is equals to X, this determinant. You have to find out the value of the X, variable X, if the value of this determinant is equals to this determinant. So, simply both are the determinants of order 2, and you know how we can find out the value of a determinant of order 2, simply multiplying the diagonal elements. So, we are given this determinant is equals to this determinant. This is what? 3, 2, x and x square, determinant 1, and this is equals to 5, 3, 3, 2. So, the value of this is what? This minus this, and likewise this minus this. So, 3x square minus twice of x, this is equals to what? 10 minus 3 into 3, 9. So, what you will get here? 3x square minus 2x is equals to 1, and this can be written as 3x square minus 2x minus 1 is equals to 0. So, this is our quadratic equation after solving these two determinants. Now, this is a quadratic equation. You can find out its solution either by factorization method. If not possible, then we can use the quadratic formula. And unfortunately, we cannot find out the factors of this quadratic equation. So, we will use the formula, that is x is equals to minus b plus minus b square minus 4ac divided by twice of a. This is known as the quadratic formula. You all have studied at your 9th or 10th standard. Now, what are the values of x? Here a is equals to 3, b is equals to minus 2 and c is equals to minus 1. A is what? A is the coefficient of x square, b is the coefficient of x, c is the constant term. So, substitute these values of this, what you will get? This is what? Minus a is 3, sorry, this is not correct, this is 3, a is 3. This is 3, so how it will work? 3x square minus 2x minus 1. B is what? Sorry, yes, right, B is 2. B is minus 2, so we will get here 2 plus minus root, B is 2, 2 square means 4, minus 4, A is what? A is 3 into C is minus 1 divided by twice of A. Now, this can be written as 2 plus minus, what is this? 4 minus minus plus 4 into 3, that is 12 divided by 2a, 2 into a is 3, that is 6. So, this can be written as 2 plus minus 12 into 4, 6, and the square root of 6 is 4 divided by 2 into 3, 6. So, the values of x are what? One is 2 plus 4 by 6 and other is 2 minus 4 by 6. So, x is, this is 1 and this is minus 2 by 3 means 2 by 6 means minus 1 upon 3. So, these are the two values of x if this determinant is equals to this determinant. So, whenever you will encounter many questions of this type, when a determinant is equals to determinant and then you have to find out the value of x, this is the best approach. Simplify the two determinants, you will get an equation and then find out the factors or the roots of the given equation to get the value of the required variable x. Similarly, this is also a question of the type of what? This is a determinant and the value of this determinant is given as 0. Solve the following determinant. So, it means what? From this determinant, you have to find out the value of x, right? So, simply let us see, we have given this determinant. See, case 1, if you don't want to use any operation, case 1 is what? This is a determinant of order 3. You can expand this determinant along any row or any column and then simplify it. You will get an equation in x and then solve that equation. You will get the value or values of x. This is method 1. But I think this method you can of course find out the solution of this question, but the calculation is lengthy and it's also time consuming. So, we will use the shortcut method to avoid any confusion as well as to make the calculations easy. Also, time saving factor also matters. So, see what we are doing here. This is our determinant, right? We are using the proper operation C1 plus C2 plus C3. Means in column 1 we are adding column 2 as well as column 3, right? It means C1 plus C2 plus C3. Column C2 and column C3, they are added to the column 1 and then see what happens. See, let us take the first element of the first column is 5x minus 1, right? The second is 5 plus 5. So what we will get here? 5x, 5 plus 5, 10 minus 1, that is 9. Sorry, plus 9. 5, 5, 10 minus 1, 5x plus 9. So after using this operation, you will get 5x plus 9, and in the same way for the second, the first element is 5 plus 5x minus 1 plus 5. So you will again get what? 5 plus 5, 10 minus 1, 9, again 5x plus 9. And similarly in the case 3, 5 plus 5x minus 1, you will get 5x plus 9. So in all the three cases, we are getting the same value, that is 5x plus 9, 5x plus 9, 5x plus 9. That is what we have written here. See this? This is our column 1, which is obtained after using the operation C1 plus C2 plus C3 in the given determinant. Clear? Now, the column is same, so what we can do? We can take it outside as common. So 5x plus 9 we have taken as common. What is left here? 1, 1, 1. So 1, 1, 1, and the rest two columns will remain as it is. Now see what we will do here. See, this is 1, this is 1, this is 1. So if we subtract R2 minus R1, so 1 minus 1 we will get here 0. R3 minus R1, then 1 minus 1 we will get here 0. Right? See, operating R2 minus R1 and R3 minus R1, these two operations simultaneously. See, R2 minus R1 means what? R2 minus R1 means we are subtracting row R1 from row R2. So what you will get here? 5x plus 9 row R2 minus R1. So row R1 will remain as it is. This is our determinant. Sorry, 5x plus 9, it will remain as it is without any change. What we will get here? R2 minus R1. What is R2? So 1, 5, 5, it will remain as it is. R2, the first element of R2 is 1. So 1 minus 1 we will get here 0. Second, 5x minus 1 minus 5. Sorry, 5x minus 1 minus 5. So you will get here 5x minus 6, right? So second is 5x minus 6. Third is what? Third is R2 minus R1. Third we will get here 5. Similarly, we can use the second notation, that is R3 minus R1. R3 minus R1. We are using the operation on the whole row, right? R3 is this is our R3 and this is our R1. So 1 minus 1 we will get here 0, 5 minus 5 we will get here 0, 5x minus 1 minus 5, 5x minus 1 minus 5 we will get here 5x minus 6, that is 6. Clear? We have used in fact two operations, R2 minus R1 means we are subtracting row 1 from row 2 and row 1 from row 3. So row 1 will remain as it is, row 2 and row 3 will change, and they have already changed. So this is the new determinant and this is equals to 0. So what we are having here, if you look at column 1, it contains 1, 0, 0. So expanding this determinant along column C1, what we will get here? See, 5x plus 9, this is as it is, into 1 into what you will get? Delete the row and column in which 1 lies. What you will get here? 5x minus 6, 0, 0, 5x minus 6, and this is equals to 0. So what you will get? The value of this is equals to 5x plus 9 as it is. Simplify this into this, minus 0 into 0 is 0. So what you will get? 5x minus 6 whole square, this is equals to 0. And we know from the very basic mathematics, whenever the product of two numbers is 0, then it implies that any one of them must be 0. So this implies either 5x plus 9 is equals to 0 or 5x minus 6 whole square is equals to 0. So, see, if 5x plus 9 is 0, this implies x is equals to minus 9 upon 5. This is value 1. We are getting this value. And if 5x minus 6 whole square, this is equals to 0, it means 5x minus 6 will be also 0. So, x will be 6 upon 5. This is value 2. So, this is how you can find the value of any variable x if the determinant itself is given as 0. I have solved this question by using these operations. As I have told you, if you don't want to use any operation, you can also use the simple way out, the expansion of a determinant of order 3. You can expand this determinant along any row or any column and you will get an equation, and then solve that equation, you will get the same values. However, the possibilities in using this approach is what the calculations may be somehow difficult, or the equation may be in degree 3 or 4. So, it may create some kind of problems to you to find out their factors. Anyway, solution you can achieve by using that method also, right? This is what if A is equals to this matrix O, then show that 3A is equals to 27 times determinant of A. O. We have already discussed almost everything about matrices, and then we came to the new notion, that is determinant. Now, this is a question which interconnects the concept of matrices and determinant, and we have already discussed square matrices have only determinants and rectangular matrices don't have any determinant, and how determinants characterizes matrices. This we also know. A determinant tells us whether the matrix is invertible or not, and we have discussed all these things when we have started the chapter of determinant. So, here what we want to show, if A is equals to this, right, matrix, be careful, this is a matrix, then show that determinant of 3A is equals to 27 times of the determinant of A. Try to understand the difference between determinant of 3A and 27 times determinant of A. 27 times of determinant of A, what does it mean? The value of a determinant is multiplied with 27. Value of a determinant is also a number. You know, determinants are always scalar. So, 27A is equals to what? The value of a determinant is multiplied by 27. You will get 27 times of determinant of A. But here 3A determinant is not the same thing. 3A determinant means this is the determinant of the matrix 3A, not the matrix A. Be careful. If the matrix is A, then its determinant is being denoted by A. So, if the matrix itself is 3A, then its determinant will be 3A, right? This is the difference between the left hand side and right hand side, right? Now, you can proceed for the solution. Say A is given this matrix, A is equals to what? 1 0 0 0 1 0 1 2 4. This is your A. What we want to calculate? This is the left hand side, take this as a left hand side and take this as a right hand side. So, first we calculate left hand side, that is determinant of 3A. So, determinant of 3A means this is a determinant of a matrix 3A, not the matrix A. Be careful. So, what we will do here, if A is this, then its determinant will be denoted by determinant of A. But what is given here, 3 times of determinant of A, 3A. So, first what we will do, find out the matrix 3A. So, 3A will be what? 3 0 0 0 3 0 3 6 12, means multiply all the elements of this determinant by 3. Clear? Are you getting the point? If A is any matrix, then its determinant is being denoted by determinant of A. right? If you want to calculate 3a, so it means if A is a determinant of the matrix A, then determinant of 3a will be the matrix of the determinant 3a. If you want to calculate here determinant 10a of determinant, so 10a determinant will be the determinant of the matrix 10a. Are you getting the difference between all these things, right? So that is why we are multiplying the given matrix by 3. So if A is this, 3a is this. Now we can determine its determinant. So this is a matrix, its determinant is now given as 3 times of this is equals to 3, 0, 0, 0, 3, 0, 3, 6 and 12, right? Now find out its value. Its value will be equals to what? 3a of determinant, this is equals to, expand it along the either first row or first column, 3, what you will get here, into this row, this column, 3, 6, 0 and 12, right? So what is the value of this? 3, 6, 0, 12 plus this is 3, this is 0 and this is 3, right? So 3 with this, now 0 into anything you will get here 0, now minus 0 into any determinant you will get 0, now the third is 3 into this row, this column, 0, 0, 3, 0, 0, 0, 3, 0. Simplify this as a calculation, we are getting its value as 108, right? Are you getting the point? Simply expand this determinant now along any row or any column. I have expanded it along the first row, you can also expand it along the first column. So now 3a is being calculated as 106. This is also 0, 0 minus 0, 0. So 3, 12 into 3, 36, 36 into 3, you will get here as 108. Now here we have given 27 times of the determinant. This is the determinant of a matrix A itself, right? Now A is this. Now find out the determinant of A. Now as usual, find out the determinant of A. What is the value of the determinant? Determinant of A is equals to what? 1, 0, 0, 0, 1, 0 and 1, 2, 4, right? Expand it along any row or any column. We are expanding it along first row, 1 into what is left here, delete this row and this column, what you will get? 1, 0 twice of 4 minus 0 into anything you will get here 0. The third is plus 1 into this row and this row, this column, 0, 0, 1, 0, right? So what you will get here? 1 into 4, this is 4 minus this term is 0, 1 into 0 into minus 0, so this is equals to 4. So 4 is the value of the determinant A. Now what we want to show? We want to show that 3 of A, its determinant is equals to 27 times of determinant of A. So 3A is coming out to be 108 and this is 27 and determinant of A is coming out to be 4. So 108 is equals to 4, 7 the 8, 28, 4 to the 8 and 2 10. So 108 is equals to 108. It means left hand side and right hand side both are equal. So this is how we can also solve a question of interdependence of matrices and determinants. I have taken this question because you can understand the relationship between matrices and determinants, how they behave. Here the matrix is given to you and then you have to show that determinant of its 3 times multiple. 3a means scalar multiplication of this matrix with 3. So you will get here 3a. If the matrix is 3a, then we will get its determinant as 3a. Now finally we come to an end. This is the last topic, that is how we can multiply two determinants. We have discussed almost everything about determinant, means expansion of a determinant along any row or any column, and I have told you a determinant can be extended in 6 ways, and in all the 6 ways your answer will be same. Second case, we have also discussed to find out the value of a determinant using Sarus diagram. If you wish, you can use the method of Sarus diagram. Third, we have also studied in properties the value of a determinant can be determined by multiplying the element with its corresponding cofactors of any row or any column. Means if the elements of any row or any column are being multiplied with their corresponding cofactors and they all are sum up, we will get the value of the determinant. And finally, if two determinants are given to you, say this is determinant d1 and this is a determinant d2, then how we can multiply these two determinants? There is a little bit difference between the approach of multiplication of two determinants as well as multiplication of two matrices. Two matrices are multiplied under what condition? That is what we have already discussed. Here we will discuss how two determinants can be multiplied. Let us denote two determinants in the discussion by, say, call it as a delta 1 to delta 2, or you can call them as d1 and d2, and the product of d1 delta 1 and delta 2 by, say, delta. So d1 into d2 you can denote it by d, or delta 1 into delta 2, the product is being denoted by delta, right? What is the approach? See, multiply the elements of the first row of delta 1 by the corresponding elements of the first row of delta 2 and add them. This will give the first element of the first row of the product. Again, multiply the elements of the second row of delta 1 by the corresponding elements of the second row of delta 2 and add them to obtain the second element of the second row of the delta. Next, multiply the elements of second row of delta 1. So, what does it mean? There is a very basic difference between multiplication of two matrices and multiplication of two determinants. In case of matrices, rows of the first matrix are always multiplied with the columns of the second matrix. But here, row of the first matrix or rows of the first matrix must be multiplied with the rows of the second matrix, right? First row, take the first row of the first determinant, the first row should be multiplied with the first row of the second determinant, then first row of the first determinant should be multiplied with the second row of the first determinant. Then take the second row, multiply the second row with the first row of the second determinant, then second row of the second determinant, then third row of the second determinant. The difference is what? Here the rows are multiplied with rows, right? In case of matrices, rows are multiplied with the columns. Next, multiply the elements of the second row of delta 1 by the corresponding elements of the first row of delta 2. Take the second row of the first determinant, multiply it with the first row of the second determinant, then multiply it with the second row of the second determinant, and then so on. So, by carrying this process, you can proceed as usual. Let us take this example, say a1, b1, a2, b2, this is a determinant, a1, a2, b1, b2, this is a determinant of order 2 and the same is multiplied with the same, a1, b1, a2, b2. So, what this product actually says? The first row should be multiplied with the first row first. So, a1 into a1 you will get here a1 square. b1 into b1 you will get here b1 square, right? First row with the first row of the second. Now, first row with the second row of the second determinant. So, what we will get? a1 a2 plus b1 b2, right? Now, come to second row. Second row must be multiplied with the first row, a1 a2 plus b1 a2, right? a1 a2, sorry, b1 b2, this is b2, b1 A1, A2 and B1, B2, right? And then this with this A2, A2 means A2 square plus B2, B2 means B2 square, right? So this is how we can multiply two determinants. Row of the first should be multiplied with the rows of the second column. Second row of the first matrix should be multiplied with all rows of the second column. Similarly, you can proceed for this question also. Express the square of the determinant means find out the square of this determinant as a third order. So this square means this determinant is multiplied by itself, right? Now take this row A1 into A1, A1 square, B1 into B1 is B1 square, 0 into 0 is 0. Now the first row with the second A1 into A2 plus B1 into B2, this by third A1 into A3, B1 into B3, you will get this, right? So what we are doing actually here, we are using the concept of rows by row. First row of the first matrix should be multiplied with the first row of the second, then the second row of the second, then the third row of the second, right? Then take the second row of the first matrix, multiply it with the first row of the second, second row of the second and third row of the second. Now take the third row of the first matrix, multiply it with the first row of the second and the second row of the second and the third row of the second. So this is how we can multiply the two determinants whether they are of order 2 or order 3. Rows of the first should be multiplied with the rows of the second column. So student, it's all about the determinant, their expansion, their definition, their properties, their questions, and then finally their product. So this is all about what I want to explain in this session. So thank you very much for your patience learning. Thank you very much.